Namaste students, welcome back to Rama Teaches You. Today we are going to do the second video on the class 11th maths chapter, permutation and combination. Okay, in the previous class we have already done the multiplication and addition law of combination. Okay, here we are going to do the factorial notation. Let's understand what factorial notation actually means. Okay, let n be a positive integer. Then the continued product of the first n natural numbers is called the n factorial. For example, if you have 3 factorial, so 3 into 2 into 1 becomes 3 factorial. 5 factorial is 5 into 4 into 3 into 2 into 1. 10 factorial is 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. So that is what a factorial actually means. Okay. So n factorial is n into n minus 1 into n minus 2 into n minus 3 into 3 into 2 into 1 all the way to 1. All the natural numbers that you have between 1 and your n will have to get multiplied. That is what a factorial means. Now 0 factorial. It does not mean any sense to define 0 factorial as the product of the integers from 0 to 1. So we define 0 factorial as 1. Okay, this is something that you have to remember. 0 factorial is what? 1. Clear? Okay. N factorial is n in, no, it's just a rule. Okay. 0 factorial represents 1. Clear? So the factorial of proper fractions or negative numbers are not defined. Negative numbers and fractions do not exist. Factorials of them do not exist. Okay. N factorial is only defined for whole numbers, that is for non-negative numbers. So you can only have factorials from 0 all the way to infinity, and they should be whole numbers. They cannot be integers, they cannot be fractions, nothing else. Okay. Now for example, compute 8 factorial upon 4 factorial. Okay, what is 8 factorial upon 4 factorial? 8 factorial represents 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1 upon 4 factorial represents 4 into 3 into 2 into 1. So can I cut this whole thing and this whole thing? Can it get cut off? So you will get 8 into 7 into 6 into 5. So 8 5s are 40, 40 into 7 5s are 7 6 are 42. So this will be 840. Clear? The answer will be 840. Easy, right? Now, is 8 factorial upon 4 factorial equal to 2 factorial? What is 2 factorial? 2 into 1, which is 2. So 840 is not equal to 2. Therefore, 8 factorial upon 4 factorial is not equal to 2 factorial. Clear? Now, evaluate n factorial upon n minus r factorial, where r is equal to 3. So you have a, wait, hold on. 8 5s are 40. 8 factorial, right? 8 into 7 into 6 into 5 into 4 factorial. 8 into 5s are 40. 7, oh, 7, 6, no. What? Oh, 42. Oh, yeah, I got it. I got my mistake. 42 into 20 is what I did. I should have done 42 into 840. I understood the mistake. Okay. So 40 into 4s are 160, 168. 1680. That should have been the answer, right? Yeah, 1680. I made a mistake. 1680. Okay, next question. Question number 2. Evaluate n factorial upon n minus r factorial, well, r is equal to 3. So n factorial upon n minus r factorial can be written as n into n minus 1 into n minus 2 into n minus 3 factorial, right? Because n minus 3, n minus 4, 3, 2, 1, you all get their answer upon n minus 3 factorial. This and this gets cut off. So you're left with n into n minus 1 into n minus 2. That is the answer. Clear? Is it perfect? Any doubts? If you have any doubts, let me know. Okay, fine. Next. Convert products into factorials. Now, 6 into 7 into 8 into 9 into 10. This can be written as what? 10 factorial upon 5 factorial, because 10 factorial is 1 to 10 all multiplied. 5 factorial is 1 to 5 all multiplied. Therefore, what will happen? To get 6, 7, 8, 9, 10, you write 10 factorial upon 5 factorial, right? Okay, next. 2, 4, 6, 8, 10. 2 into 4 into 6 into 8 into 10. Okay, how can you write this? Can you remove basically this? Drupad, look at this. Can I write it as 2 into 2 into 2 into 2 into 3 into 2 into 4 into 2 into 5? Can I write it like this? 2 is 2, 4 is 2 into 2, 6 is 2 into 3, 8 is 2 into 4, and 10 is 2 into 5. So if I take these two out, this 2, this 2, this 2, this 2, and this 2, I'll get 2 to the power 5 into 2 into 3 into 4 into 5. And obviously I can write multiplied by 1 also. Okay, so 1 into 2 into 3 into 4 into 5 is how much? 5 factorial multiplied by 2 to the power 5. Easy? Okay, how can you write 3 into 9 into 27 into 81 into 243? How can you write this? Oh, no, sorry. I'm so sorry. 3 into 6 into 9 into 12 into 15. How can you write this? 3 into 3 into 2 into 3 into 3 into 3 into 4 into 3 into 5 into 1. Okay, so basically this 3, you can even write this as, instead of saying 3 into 1, instead of giving a multiplied by 1 at the end, you can call this 3 into 1. Much better. So 1, 2, 3, 4, 5. This will be 5 factorial. 1, 2, 3, 4, 5 will be 3 to the power of 5. Clear? Easy? Yeah. Okay, let's move on. Next, 12 factorial minus 10 factorial upon 9 factorial. Okay, how will we write this? Okay, so you have 12 factorial minus 10 factorial upon 9 factorial. Just hold on. Okay, so this is what we did. I accidentally did not show the screen, but this is what we're supposed to do. Okay, this is what we're doing. Okay, so this can be written as 12 into 11 into 10 factorial minus 10 factorial upon 9 factorial. Am I right? So I can remove the 10 factorial from top. If I remove the 10 factorial, what will be left with? 12 into 11s are 132, right? Minus 1 upon 9 factorial. This can again be written as 10 into 9 factorial multiplied by 132 minus 1 upon 9 factorial. This and this gets cut off. So what will I be left with? 10 into 132 minus 1. That is 1320 minus 10, 1310. Simple? Okay, let's move on to the next question. Find the LCM of 3 factorial, 7 factorial, and 8 factorial. Okay, we have to find the LCM. How will we do this? See, LCM is the lowest common multiple that you have. Okay, now let's look at this. The highest number will be the LCM always. I'll show you how. You have 6 factorial is what? 6 factorial, right, like this. 7 factorial is 6 factorial into 7. 8 factorial is 6 factorial into 7 into 8. So basically 6 factorial also comes in the multiple of 8. Okay, 8 factorial. 7 factorial also comes in the multiple of 8 factorial. 8 factorial also comes in the multiple of 8 factorial. Understood? So 6 factorial multiplied by 7 into 8 is 56. Sorry, 7 8 are 56 is equal to 8 factorial. 7 factorial multiplied by 8 is equal to 8 factorial. And 8 factorial multiplied by 1 is equal to 8 factorial. So you're getting an LCM anyways. This 8 factorial becomes the lowest common multiple of all of them. Perfect. Next one. So you have 1 upon 7 factorial plus 1 upon 9 factorial is equal to x upon 10 factorial. So if I make the denominators the same, what do I get? This will be 7 factorial and this will be 9 factorial. To make 7 factorial into 9 factorial, what should I do? 1 upon 7 factorial multiplied by what? 8 multiplied by 9 multiplied by 10 upon 8 multiplied by 9 multiplied by 10 plus 1 upon 9 factorial multiplied by 10 multiplied by 10 is equal to x upon 10 factorial. So the denominator in both the LHS and the RHS have now become the same. 7 factorial into 8 into 9 into 10 is what? 10 factorial. And 8 9s are 720 plus. So n plus 3 factorial is equal to 56 multiplied by n plus 1 factorial. Then find the value of n. So this is n plus 3 factorial, right? N plus 3 factorial can be written as what? N plus 3 into n plus 2 into n plus 1 factorial is equal to 56 multiplied by n plus 1 factorial. Am I right? This n plus 1 factorial and this n plus 1 factorial gets cut off. Therefore, n plus 3 into n plus 2 is equal to 56. N square plus 2n plus 3n plus 6 is equal to 56. Plus, yeah, n square plus 5n plus 6 minus 56 is minus 50 is equal to 0. So you will get two solutions for this equation. What are they? 50 and 5. How do I get 50 and 5? Plus 10 minus. Very good. N square plus 10n minus 5n minus 50 is equal to 0. n into n plus 10 minus 5 into n plus 10 is equal to 0, n plus 10, n minus 5 is equal to 0, n is equal to minus 10 comma 5. Clear? N will be 5. Exactly, n will be 5 because n cannot be negative. Okay, clear? Let's do the next question. You also bring a notebook and a pen with you so that you and I both can do together. Okay, I'll hold on. Question 8. So we have 2n factorial upon n factorial is equal to 1.3.5 dot 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 2 to the power n minus 1. Okay, so basically how will we do this? How can we do this? 2n factorial. 2n factorial, how can we do this? 2n factorial can be written as what? 2n factorial can be written as 2 into, sorry, let's start with 2n 2n minus 1 2n minus 2 dot 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 5 into 4 into 3 into 2 into 1 upon n factorial. Correct? This is the first line that we can write, right? Yeah. So now you have can I oh yeah, got it. So what can we do? Let's see, I'll show you something. We have this 1 3 5 7 9, then you have 2 to the power of n minus 1. Let's bring all of them together. Okay, so I can write it as 1 multiplied by 3 multiplied by 5 multiplied by 7 dot 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 2 to the power of n minus 1 multiplied by what is left behind. You have 2 4 2 to the power minus 2 and 2n. You have basically 2 into 4 into dot 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 2 to the power 2n minus 2 into 2n upon n factorial. So you have 1 into 3 into 5 into dot 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 2 raised to the power n minus 1 multiplied by, if I take the 2 out, what do I get? 2, how many 2's are there? N 2's are there. Okay, so 2 to the power of n, you have 1 into 2 into 3 into n minus 1 into n upon n factorial. This is equal to 1 into 3 into 5 into 2 to the power of n minus 1 dot 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 multiplied by 2 to the power of n. This can be written as n factorial upon n factorial. This and this gets cut off. So you will have 1 into 3 into 5 into dot 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 2 ki power n minus 1 into 2 ki power of n. That's it, finished. Is equal to RHS. LHS is equal to RHS. Do you see what I did? Yeah. Clear? This was a good question. Yeah. Put a star next to it in the brackets, okay? Now, yeah, if n factorial upon this one, n factorial upon 2 factorial into n minus 2 factorial and n factorial upon 4 factorial into n minus 4 factorial are in the ratio of 2:1. Find the value of n. So first we have to somehow manipulate these two. What do we do? I can write this as n factorial can be written as n into n minus 1 into n minus 2 factorial upon 2 factorial into n minus 2 factorial, and you have n factorial into n minus 1 into n minus 2 into n minus 3 into n minus 4 factorial upon 4 factorial into n minus 4 factorial. This and this gets cut off. This and this gets cut off. So we need to check the ratios. Okay. So what are the ratios that are left? In the top you have n into n minus 1 into, there is no into anymore, 2 into 1, that is 2 factorial is 2 into 1, the whole upon n into n minus 1 into n minus 2 into n minus 3 upon 4 into 3 into 2 into 1, and the ratio is how much? 2:1 is equal to 2 upon 1. Okay, so what do I get? N and n gets cut off, n minus 1 n minus 1 gets cut off. So what is left behind? So basically this goes here and this goes here. So what do we get? 4 into 3 into 2 into 1 upon 2 into 1 into n minus 2 into n minus 3. This and this gets cut off. This and this gets cut off. So you have 4 into 3 upon n minus 2 into n minus 1 is equal to 2 upon 1. This 2 and this becomes 2. So you have 6 upon n minus 1 into n minus 2 is equal to 1 upon 1. Cross multiply. What do you get? 6 is equal to n minus 1 into n minus 2. 6 is equal to n square minus 2n minus n plus 2. 6 is equal to n square minus 3n plus 2. So n square minus 3n plus 2 minus 6 is equal to 0. N square minus 3n minus 4 is equal to 0. Therefore, you have, what will be the answer here? N square minus 4n plus n minus 4 is equal to 0. N into n minus 4 plus 1 into n minus 4 is equal to 0. N plus 1 into n minus 4 is equal to 0. N is equal to minus 1 comma 4. N cannot be minus 1, therefore n is equal to 4. Clear? Easy? It's very easy, right? Okay, let's, oh wait, I made a mistake. Oh my god, what mistake did I make? One second.
And 2 and 3 root that minus 2 can some
Where? Oh, got it. I got it. I made a mistake. I hear, yeah, I see that. So this was supposed to be n minus 2 into n minus 3. It's a very careless mistake. I shouldn't have made it. Okay, so okay, so we have n square minus 2n minus 3n plus 6 is equal to 6. This is equal, this is correct, right? This is what I have written. Yeah, it's correct. So n squared minus 5n is equal to 0, n into n minus 5 equals 0. So either n is equal to 0 or n is equal to 5. Okay, so the answer is n is equal to 5. Why? Because why are we rejecting this? Because n is equal to 0, then n minus 2 factorial and n minus 4 factorial are not defined, right? That is why the reason why we are taking n is equal to 0 as incorrect. So we just remove it. Clear? So this is how you solve the question. Okay, small mistake, but still this is how you solve the question. Next one, prove that n factorial the whole square is less than or equal to n factorial is multiplied by n to the power of n is less than 2n factorial for all n belongs to n. So what is n factorial the whole square, Drupad? N factorial multiplied by n factorial, right? Okay, so this can be written as n factorial multiplied by 1 into 2 into 3 dot 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 multiplied by n. Okay, now is this should be, this is n factorial the whole square. Now basically the next is n factorial into n to the power of n. Okay, now what do I get from this? N factorial the whole square is this value, n factorial into n to the power n, that is r is less than or equal to n, for which r is equal to 1 2 3 dash dash n. Therefore n factorial the whole square is less than or equal to n factorial times n to the power of n. Okay, this is the reason why it is less. Did you understand this? Okay, why? Because see here n fact n to the power of n is a huge number. Okay, n to the power of n is n into n into n into n into n. So basically it's not what, when we are doing n factorial the whole square, you are multiplying it with this, but here we are getting a bigger value. Okay, so n factorial into 1 into 2 into 3 into dash dash n, so it has to be less than n to the power of n, right? Because when you have n to the power of n, what do you get? N into n into n into n into n. So basically instead of 1 you have n, instead of 2 you have n, instead of 3 you have n. So basically this is smaller than this number. Okay,
Yeah.
so this is smaller, that's why the LHS is correct. Now for the RHS, 2 to the 2n factorial can be written as what? 1 into 2 into 3 into n factorial plus n plus 1 into n plus 2 into 2n factorial. So which has to be greater than n factorial into n to the power of n. Why? Because when you had n to the power of n, you were multiplying n into n into n into dot 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 n n times. But when you have 2n factorial, sorry, 2n factorial, you have 2n into, you have 2n factorial is equal to 2n into 2n minus 1 into 2n minus 2 into 2n minus 3. So every single number is greater than n. In this case, look at this, every single number, n plus 1 n plus 2 dash 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 2n, all of these numbers are greater than n, and they are being multiplied how many times? N times. So basically, this will be greater than 2n factorial. This will be lesser than 2n factorial. Okay? If you did not understand, ask me. Okay? So basically, the reason for 2n factorial to be greater, okay, I'll explain it once more. Okay? 2n factorial can be written as 1 into 2 into dot 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 n. This whole thing is what? N factorial, right?
Yeah.
Multiplied by n plus 1 n plus 2 2n factorial.
Mhm.
How many n's are there here? There are n terms here. N square, n to the power n has how many terms? This also has n terms. For example, 3 cubed has how many terms? 3 into 3 into 3. 3 terms, right? So, n to the power of n is equal to, you have n terms of n into n into n into dot 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 n. This is n terms. Clear? So, here you have n terms here. You are here also you have n terms here. But this is n, this is n plus 1, this is n, this is n plus 2. Every single number that is being multiplied here is greater than what is being multiplied here.
Yeah.
Every, see, basically it's like this. You have 3 into 3 into dot 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 3, right? But here you are having 3 plus 1, 4 into 5 into dot dot dot, something like that. Okay, so this will always be bigger. So this is how you prove it, by writing basic statements. Okay, next one. What is the largest integer n such that 33, what is the largest integer n such that 33 factorial is divisible by 2n? Hmm. So 33 factorial can be written as 1 into 2 into 3 into dot 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 31 into 32 into 33. Okay, now I'm going to take out all the even numbers and odd numbers separately. So if I take all the odd numbers, what happens? 1 into, sorry, 1 into 3 into 5 into dot 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 31 into 33 multiplied by 2 into 4 into 6 into 8 into, then you have 10 into 12 into 14 into 16 into 18 into 20 into 22 into 24 into 26 into 28 into 30 into 32. Okay, so let's see. 1 into 3 into 5 into dot 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 31 into 32. This is 2 to the power of 1 into 2 square into 2 into 3, 2 to the power 1 into 3 into 2 cube. We have done this into 2 into 5 into 2 squared into 3. This is also done into 2 into 7, done into 2 to the power 4, done. 18 can be written as 2 into 3 squared into, this is also done. So you will have 2 into 11, 8, no, I forgot the 20. 2 square into 5 into, done. 2 into 11 into, done. 12 to the 2 cubed into 3 into 2 keep 26 is what? 13 into 2 into 13 into 28 is what? 14 2s are 28. 2 square into 7. Okay, into 10 3. 2 into 3 into 5 into 2 की power 5. Okay, now so 2 की power, so 1 into 3 into 5 into dot 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 31 into 32, 2 to the power of 1 plus 2, done, plus 1 plus 3 plus 1 plus 2 plus 1 plus 4 plus 1 plus 2 plus 1 plus 3 plus 2 plus 1 plus 2 plus 1 plus 5, and into what all are there? 3 into 5 into 3 into 7 into 3 squared into 5 into 11 into 3 into 13 into 7 into 3 into 5. That's it. Okay, now let's see if all of them add up to 31 or 2 to the power of 31 or not. 1 plus 2 is 3, 4, 5, 6, 7, 8, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 15, 16, 17, 18, 19, 20, 19, 22, 23, 24, 25, 30, 31. Is it 2 to the power of 31? Yeah, that's it. So you have this whole thing. You will get 2 to the power of 31 multiplied by 1 into 3 into 5 into 7 into 31 into 33. This is 33 into 3 into 5. This can be written as what? 3 into 3 into 3. 1, 2, 3, 4, 5, 6. 3 to the power of 6. 5, 1, 2, 3. 5 cubed. 7 squared. 11 into 13. Okay, so basically this whole number, because it is multiplied by 2 to the power of 31, it is divisible by 2 to the power of 31. Did you understand the logic behind this question?
Yeah.
Okay, you have to explain this. You have to show that the calculation is actually coming out to 2 to the power of 31. You can't just leave it there. Understood? Okay, let's actually do these questions. These are, I think, very important questions, I guess. So first one, find the value of 1 into 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial plus dash 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 n into n factorial. What will the value be, Drupad? How can you do this? 1 into 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial plus n into n factorial. Try this out. So just tell me what all we have to do.
Yeah. The thing.
Hmm? What? Just one second. Just try think about it. Okay. This can be written as, yeah, no, let's actually look at this. So okay, so this can be written as 2 factorial minus 1 factorial plus 3 factorial minus 2 factorial Hmm. 2 into 2 factorial is equal to 2 factorial is 2, 2 into 2 is 4, 3 factorial is 3, 3 6, 6 minus 2 is 4. Yeah, this is coming out to be correct. Plus this can be written as 3 factorial, sorry, 4 factorial, 4 factorial minus 3 factorial, plus this can be written as n plus 1 factorial minus n factorial. Correct? Okay. So let's actually open it up. What do we get? 2 factorial minus 1 factorial plus 3 factorial minus 2 factorial plus 4 factorial minus 3 factorial plus n minus 1. Wait. N plus 1 factorial minus n factorial. Okay. So this will be n minus 2 factorial minus n minus 3 factorial plus n minus 1 factorial minus n minus 2 factorial plus uh, n factorial minus n minus 1 factorial plus n plus 1 factorial minus I'll get n factorial. So what happens? So basically 2 factorial plus 2 factorial minus 2 factorial gets cut off. Plus 3 factorial minus 3 factorial will get cut off. Plus 4 factorial minus 4 factorial will get cut off. N minus 2 factorial and n minus 2 factorial will get cut off. This and this will get cut off. N minus 1 and this will get cut off. This and this will get cut off. So you'll be left with n plus 1 factorial minus 1 factorial. Therefore, n plus 1 factorial minus 1. This is the answer. I want you to write this down, Drupad, in your notebook. Write it down. Question number 2. N plus 1 factorial is equal to 12 into n minus 1 factorial. This is a very easy question, right? You can write this as basically n minus 1 factorial dot n factor n into n plus 1. Am I right? This can be written as that n minus 1 factorial into n plus 1 factorial. Sorry, n minus 1 factorial into n plus 1 is equal to 12 into n minus 1 factorial. This and this will get cancelled. N square plus n minus, so minus 12 is equal to 0. Clear? So you will have n square plus 4n minus 3n minus 12 is equal to 0. N into n plus 4 minus 3 into n plus 4 is equal to 0. N plus 4 into n minus 3 equals 0. N is equal to minus 4 comma 3. N is equal to 3 is the answer. Clear? This was easy, right? Very good. Next. Done? Next. Evaluate the following. 4 factorial minus 3 factorial. 4 factorial minus 3 factorial. 4 into, yeah, exactly, minus 3 factorial is equal to 3 factorial 4 minus 1 is equal to 3 factorial multiplied by 3. What is 3 factorial? 6.
Okay.
18. 23, 18. Okay. Next one. 2 multiplied by 6 factorial minus 3 multiplied by 5 factorial. So this can be written as 2 multiplied by 6 multiplied by 5 factorial minus 3 multiplied by 5 factorial. So you will get 5 factorial outside. 12 minus 3. 5 factorial multiplied by 9. What is 5 factorial? 5 into 4s are 20, 20 into 3s are 60, 60 into 2s are 120. Minus 9 is equal to 111 is what? Oh, sorry. What am I doing today? 120 multiplied by 9. So 9 zeros are 0, 9 twos are 18, 1 9 was a 9, 1080. Okay, that is correct. Clear?
Yeah.
Next, evaluate. Question number 4. 20 factorial upon 18 factorial multiplied by 20 minus 18 factorial. You also do it, Drupad. I think you will be able to do it faster than me. Okay, try doing it. So this can be written as 20 into 19 into 18 factorial upon 18 factorial into 2 factorial. So this and this gets cut off. So 20 into 19 upon 2 into 1. So you'll get 10, 190. Is the answer 190? Did you also get 190? Okay, very good. Okay, try solving it before me, Drupad. I want you to be faster than me. If 1 upon 9 factorial plus 1 upon 10 factorial is equal to x upon 11 factorial, you basically make the denominator as 11 factorial. To do that, what do you do? So, 10 into 11 upon 9 in 9 factorial into 10 into 11 plus 1 upon 10 factorial multiplied by 11 is equal to x upon 11 factorial. So 110 upon 11 factorial plus 11 upon 11 factorial is equal to x upon 11 factorial. So 110 plus 11 is equal to x upon 11 factorial upon 11 factorial. This is cut off. So you get 1 and 121, right? Is
Yeah.
equal to x. Next. Okay. You have 1 upon 8 factorial. Question number 6, you do it yourself. This is just a repeat. You do it yourself. You will get 100. Very good. Answer is equal to 100. Okay. Now, prove that n into n minus 1 into n minus 2 dot 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 n minus r plus 1 is equal to n factorial upon n minus r factorial. Okay. How will we do this? How will we do this, Rupert? But multiply the LHS and the RHS by n minus r. Okay, you multiply both of them. In the LHS, multiply numerator and denominator by n minus r factorial. Okay, fine. So you will have, let's see, you have n into n minus 1, n minus 2, dot dot dot, n minus r plus 1 factorial upon n minus r factorial, okay, is equal to n factorial upon n minus. Now we have to prove that. We have to prove this. Okay, so you multiplied and divided. Okay, you multiplied the numerator and the denominator by n minus r factorial. the denominator, that is n minus r factorial multiplied by n minus r factorial. Okay, so what do you get? N into n minus 1 into n minus 2. So dot 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 n minus r plus 1
Sir,
hmm.
you right? Yes, sir. Curious as
Hmm? What?
just just one
You could do that. Yeah, let's do that. So let's see. You have n into n minus 1 into n minus 2. No, wait. You can write this as n factorial upon n minus r factorial is equal to n into n minus 1 into n minus 2 dot 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 n minus r plus 1 dot n minus r factorial upon n minus r factorial. So this and this would get cancelled. Okay, yeah, therefore you will get n into n minus 1 into n minus 2 dot 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 n minus r plus 1. So in these type of questions, Drupad, I would really like you, if you want to do it as fast as possible, just take the value of n as 10 and r as 7, any random number, so that it becomes easy for you. So basically, Drupad, look at this. So you will have 10 into 9 into 8 into n minus r. 10 minus 7 is what? 3, right? So 10 minus 7 is 3 plus 1, that is 4 factorial. So we'll go till 4 factorial. Okay, so you will have 8 into 7 into 6 into 5 into 4 factorial, and n minus r is what? Into 3 factorial. Okay, clear? So 3 factorial upon n minus r becomes what? N minus r becomes 3 factorial, and this gets cut off. So here you will be left with the answer. So this is n minus r plus 1. So many a times, instead of breaking your head like this, it is easy to put in the values and get the number yourself. Clear? Next question. Question 8. So convert the following products into factorials: n plus 1 into n plus 2 into n plus 3 into 2n. So this will be 2n factorial upon n factorial, right?
yeah.
Correct? This was a direct easy question, because you can write it as n factorial multiplied by n plus 1 into n plus 2 into n plus 3 dot 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 2n upon n factorial. This and this gets cut off. We'll be left with this. So this is the answer. Next, prove that n factorial into n plus 2 factorial is equal to n factorial plus n plus 1 factorial. Okay, n factorial. Question: n factorial multiplied by n plus 2 is equal to n factorial plus n plus 1 factorial. Okay, we have to prove this. Yeah. So let's look at the RHS. N factorial plus you have n factorial into n plus 1 is equal to, let's remove the n factorial outside. So we'll have n factorial 1 plus n plus 1 is equal to n factorial into n plus 2. Clear? Very good. Now, question number 10. 2 plus 3 factorial is equal to, which of the following are true or false? 2 plus 3 is equal to 2 factorial plus 3 factorial. Is this correct? No. What is 2 plus 3 factorial? 5 factorial is 120. What is 2 factorial? 2. What is 3 factorial? 6. 2 plus 6, 4 plus 6 is 10. So this is incorrect. Now, 2 into 3 factorial is equal to 2 factorial into 3 factorial. So this is also not correct, right?
Yeah.
Because 6 factorial is how much? 12, 12, 5, 12, 6, 720. 6 factorial is equal to 720. 2 factorial is 4. 3 factorial is, sorry, 2 factorial is 2. I'm so sorry. 2 multiplied by 3 factorial is 6. There is 12. No way in hell. Okay, so this is basically one formula. A plus B factorial is not equal to A factorial plus B factorial. Okay, A multiplied by B factorial is not equal to A factorial B factorial. Correct? This is what they want you to remember. Next, find n if n plus 2 factorial is equal to 2550 multiplied by n factorial. This is easy. Find the value of n, Drupad. Solve it. Oh, again careless mistakes. Yeah, that's correct. Just hold on. What is 9 plus 4, 8 is 32, 3, 4, 4, 16, 17, 18, 9, 1, 9, 1, 4, 2 is How did you get 49 and 52?
Because somebody,
I know, but how did you know that 49 into 52 is 4548?
I just,
Oh, you did that. But this would have been easier, no? 4 fours
yeah,
are 16, 17, 8, 1, 9, 1. 1, 4 fives are 20. The 1, 2, 4 twos are 8. 1, 0, 1, 9, 2. Okay, fine. What is the answer that you're getting?
49.
N is equal to 49. Okay, fine. Okay, next. Next question. Prove that n factorial into n minus r factorial into r factorial plus n factorial upon n minus r plus 1 factorial into r minus 1 factorial is equal to n factorial upon r factorial into n minus r plus 1 factorial. I think this is easy, Drupad. So, how can we write this? So, n factorial upon n minus r factorial into r factorial. One second. N factorial upon n minus r factorial into r factorial plus n factorial upon n minus r plus 1 factorial into r minus 1 factorial is equal to, let's actually look at this. So, yeah, okay. So I wrote n minus r factorial just like that, but r factorial I wrote r into r minus 1 factorial, and n minus r plus 1 factorial I wrote it as n minus r factorial into n minus r plus 1 into r minus 1 factorial. So I can take the n factorial out up, and I can take out this and this one, n minus r factorial into r minus 1 factorial 1 upon r plus 1 upon n minus r plus 1. So n factorial upon n minus r factorial into r minus 1 factorial into n minus r plus 1 plus r upon r into n minus r plus 1. Okay. n factorial into n plus 1 becomes n plus 1 factorial, right?
Yeah.
R minus 1 factorial into r becomes r factorial, right? R minus 1 factorial into r becomes r factorial. N minus r into n minus r plus 1 becomes n minus r plus 1 factorial. Done.
Yeah.
Finished. Yeah, that's what we were supposed to do. Clear? Write this down. Okay. Next, you have 2n plus 1 factorial upon n factorial is equal to 2 to the power of n 1 multiplied by 3 multiplied by 5 multiplied by 2 to the power of n minus 1 multiplied by 2 to the power of n plus 1. I think this is also pretty easy question only. Shall we do it? So you have 2 to the power of n plus 1 factorial can be written as 1 into 2 into 3 into 4 into 5 into dot 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 n into n plus 1 uh, into n plus 2 dot 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 2n into wait n plus 1 into n plus 2 into plus 3 into n plus 4 into, so I'll get 2n into 2n minus 1 minus 1 into 2n into 2n plus 1. Okay, this is 2n plus 1 factorial. You're correct?
Yeah.
Upon n factorial. So this becomes n factorial into, hold on. So let us take something common. 2, 4, then uh, you have 2n. So this can be written as 2 into 4 into 6 into 2n into 1 into 3 into 5 into 2n minus 1 into 2n plus 1 upon n factorial. I'll take the 2 out. 2 into 2 into 2 into 2 into 3 into dot 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 2 into n 1 into 3 into 5 into dot 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 2n minus 1 into 2n plus 1 upon n factorial. This can be written as 2 to the power of n into 2 into 1 into 1 into 2 into 3 into n into 1 into 3 into 5 into 2n minus 1 into 2n plus 1 upon n factorial. This whole thing can be written as n factorial. This and this will get cut off. So we'll be left with 2n into 1 into 3 into 5 into 2n minus 1 into 2n plus 1. That's it. Finished. Clear?
yeah.
Write it down. The next question is going to be a very lengthy question, but we have to solve these type of questions to make ourselves better. Okay. So you have proved that question number 14. 35 35 factorial is divisible by, I want you to do this with me, Drupad. Okay, by 2 to the power of 12. So 35 factorial can be written as what? 1 into 2 into 3 into 4 into 5 into 33 into 34 into 35, right? Okay, so here what I'm going to do is I'm going to take all the two terms together. Okay, all the even terms. 2 into 4 into 6 into 8 into 10 into 12 into 14 into 16 into 18 into 20 into 22 into 24 into 26 into 28 into 30 into 32 into 34. My god, we just want 2 to the power of 12, right? Huh?
Yeah.
I don't think we have to use all of them. 2 to the, yeah, okay. This will be multiplied by 1 into 3 into uh, 5 into 33 into 35. So this will be 2 to the power of 1 multiplied by 2 to the power of 2 multiplied by 2 into 3 multiplied by 2 cubed multiplied by 2 into 5 multiplied by 2 into 2 into 3, 2 square into 3, 2 square into 3. Have you reached 12? 2, 3, 4, 5, 6, 7, 8, 9, 10. We just need a couple more. Multiplied by, this is 12, right? 2 multiplied by 7 multiplied by 2 multiplied by 2 to the power of 4. That's it. We have reached 2 to the power of 12. Is it 2 to the power of 12 or 2 to the power of 21? Yeah, this is more than enough. Okay, so this can be written as 2 to the power of 1 into, this will be 2 to the power of 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 2 to the power of 14. Okay, basically this whole thing will have a lot of 2's. Okay, you just have to remove the 2's together. Okay, so if you keep this, you will can write it as 2 to the power of 12 multiplied by some huge value. Okay, so this will be divisible by 2 to the power of 12. That's it. I don't think you needed to use all the numbers, all the values or anything like that. Okay, but if they had given you the actual value, then you have to solve everything like we did in the previous question where they asked us to calculate 2 to the power of 31, right? Yeah, for 2 to the power of 31 you need to do the calculation, the complete calculation is required. Okay, that's it. This is more than enough. Okay, I think another way would have been, another way would have been, easier way would have been just to write 35 factorial is equal to 1 into 2 into 3 dot 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 35. Okay, so you will have basically 1 into 2 into 1 into basically 3 into 2 into 2 into 4 into 2 into 3 into just till 12 terms, and you take all the 12 out, all the 2 out, and again you will still be able to divide it by 2 to the power of 12. Clear?
Yeah.
So instead of 2 to the power something, just 2 into 6 are 12. So basically you will have 12 terms, and that would have been much easier. Okay, next 15. So you have 2 to the power n 2n factorial upon 3 factorial into 2n minus 3. Huh? Oh, we had to do it. Anyways, we have to do it. My God. Okay, fine. I shouldn't have erased it. So you have, we were in the right path only. You have 35 factorial is equal to 1 into 2 into 3 into dot 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 35. This can be written as basically 1 into 3 into 5 into dot 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 31 into 33 into 35, and you will have 2 into 4 into 6 into 8 into 10, then 12 into 14 into 16 into 18 into 20, 22 into 24 into 26 into 28 into 30, 32 into 34. So let's just start cutting it. 2 into 2 square into 2 into 3, then 2 to the power of 4 into 2 into 5 into 2 into 2 into 2 into 2 into 3, that is 2 square into 3 into 2 into 7 into 2 to the power of 4 into 2 into 9s are 18 into 2 into 2 and 2 square into 5. So this also done. 2 into 11, this also done. 12, 2 to the 4, 4 to the 8, 8, 2 cubed into 3, this also done, into 2 into 13 into this also done. 7, 2 in 2 square into 7, uh 3 into and 30 is what? 2 into 5 into 3 into 632 is 2 to the power of 5 into 34 is what? Yeah, 2 into 17. Okay, so hmm, that is the complete answer. Yeah, 2 raised to the power 32. Did you calculate it, or did you have a formula for it? Okay, fine. Okay, very good. So 2 raised to the power 32 into all the other nonsense will be the value. Okay, into 1 into 3 into dot 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 dot, 31 into 33 into 35, and then you will have all the rest of the values like this, 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 this. You will write all of them, and you will say that it is divisible by 32. Okay, next question. Question number 15. You have 2n the whole to the 2n factorial upon 3 factorial into 2n minus 3 factorial. I think this is easy. And n factorial upon 2 factorial into n minus 2 factorial are in the ratio of 44 is to 3. So this, let's solve it. 2n factorial can be written as 2n into 2n minus 1 into 2n minus 2 into 2n minus 3 upon 3 factorial into 2n minus 3 factorial. This and this gets cut off. N factorial can be written as n into n minus 1 into n minus 2 factorial upon 2 factorial into n minus 2 factorial. This and this gets cut off. Okay, so 2n factorial can be written as 2n and this is n. So let's actually put them in the denominator. So 2n into 2n minus 1 2n minus 2 upon 3 and 3 factorial multiplied by 2 factorial upon n into n minus 1. I wrote it directly by flipping it. I wrote it directly. Okay, so this n and this n can get cut off. This n minus 1 into 2 is equal to 2n minus 2. Okay, clear? So you're left with a 2 and a 2 factorial here and a 2n minus 1 factorial, and at the bottom you have a 3 factorial. Okay, so 3 factorial can be written as 3 into 2 into 1. This will be 2 into 2 into 2 into 2n minus 1. Okay, so this and this gets cut off. So 4 into 2n minus 1 upon 3 is equal to 44 upon 3. So 8n minus 4 is equal to 44 if I cut these two off. So I'll get 8n is equal to 48. N is equal to 48 upon 8 is equal to 6. The value of n comes out to be 6. Clear?
Yeah.
Okay. 1 second. So n is coming out to be 6. That's the final answer. So the next topic that we have to do is permutation. Don't worry, Drupad, this was the longest. Okay, always, and the factorial is the longest of all. Okay, so the next topic, we have to start the next topic: permutation and combination. Permutation, restricted permutation, and then you have combination. Shall we start this topic in the next class? Permutation section.
Yeah.
Okay, so sorry about today's delay, though. Okay, I lost the link. Okay, I was trying to search the whole WhatsApp, but somehow I lost the link. So we'll continue this permutation. I think we'll be able to finish permutation as well as restricted permutation in the next class. Okay, tomorrow. Okay, can I ask you one more thing, Drupat? Is 12? Can you do like half an hour before 12 o'clock, like 11:30, or is 12 o'clock fine?
Indian code.
Indian time, yeah.
But
So we are going to complete this topic on permutation and combination in the next class. Okay. So I think in 3 videos, the 3 upcoming videos, we will be able to finish this chapter completely. Okay, A to Z. This is a huge chapter though. Okay, so it is better for us to take the time. Like if the reason I did the factorial questions, all the factorial questions, is because I know that there are some topics that requires special attention. Okay, so we have done all the factorial questions. We will do all the permutation and combination questions, restricted permutation questions. I will try my hardest to finish the chapter in 2 videos, but I can promise that in 3 videos this chapter will get over. So this whole chapter can be finished in 5 videos. Okay. So I know the permutation is required taking a little bit more time. Linear inequalities only took like 2 videos to complete the whole chapter. Complex numbers also was like 2 videos. Some chapters are very tough. Okay, so we need the extra attention to complete it. Okay, so if you do like my videos and if you like this long ended videos where you can practice the questions with me, okay, and see where I make the mistakes and try not to make the mistakes. If you like such videos, please do like, share, and subscribe, and I will see you in the next video. Thank you so much. Bye.